Linear Relations CI-CAN for Year 9. So really quickly, state the coordinates of the x and y intercepts. Read the scale, that's 5, so each of these is 1. The y-intercept is at 3, so that's at 0, 3. And the x-intercept, those are also 1 value units, so that's at -1 on the x, and of course 0 on the y. Choose the line from this list which has each of these characteristics, so a separate line from each, remembering that you're using y equals mx plus b. This is your gradient. This is your y-intercept. We want a line that passes through the origin. That will have a y-intercept of 0, so y equals 4x passes through the origin. The line which is the steepest will have the highest gradient, 9, 4, 3, -5, so 9. Has the y-intercept 0, 3. The y-intercept is at the end there, so I'm looking for a y-intercept of 3. Passes through the point 3, 2, so I'm going to assume it's this one and check that because all the others have been used. That's our x, that's our y. I'm going to substitute x into this to make sure I get a y value of 2. So y equals 3 times x is 3, minus 7. Y is 9 minus 7, which is 2. Yes, I got the point 3, 2. Complete the table of values and graph the line that has equation y equals -2x plus 3. So when x is -3, -2 times -3 is 6. 6 plus 3 is 9. When x is -2, -2 times -2 is 4, plus 3 is 7. -1 times -2 is 2, plus 3 is 5. 0x will just give me 3. -2 times 1 is -2, plus 3 is 1. -2 times 2 is -4, plus 3, -1. And -6 plus 3, -3. A quick check before you get carried away with your graphing. The gradient should always be the pattern that I see here. -2, -2, -2, -2, -2, -2. Good, that was correct. And the y-intercept is the value when x is 0. So I got that right. So there's always a little check that you can do to make sure you got the correct numbers. Graph your points. Check the scales. Yes, each gradation is 1. -3, 9. -2, 7. -1, 5. 0, 3. 1, 1. 2, -1. 3, -3. Those should always add up and end up in a straight line. So if something doesn't, there's something wrong. Put a line through it, arrows at either end, label it with the equation y equals -2x plus 3. Penny's water bottle has 100 mils of water in it. She goes to the bubbler and fills it at 50 mils per second. The water bottle will hold 500 ml. Fill in the table of values for time elapsed in seconds and volume of water in the bottle. Then we'll plot the points and answer the questions. So it starts at 0 time at 100 ml, and we're adding 50 ml. All right, plot the points. 100, moving across 1, 150, 200, 7, 8, and put your line through it. Now normally I'd go across the axis here, but because time doesn't go back beyond 0. A lot of real life situations, you just stay in the first quadrant. How many mils in the water bottle after 4.5 seconds? All right, well that's halfway between, but we might as well show proper working by finding an equation for the line. We want y equals mx plus b. Now our y is not y anymore, it's v. Our gradient is the rate of change, so it's 50. Our x is t, and we start with a y-intercept of 100. So there's our equation. So I might as well use the equation, v equals 50t plus 100, to work that out for 4.5t. 50 times 4.5 plus 100, and we'll get to 225, 325. The volume will be 325 mil. How many seconds until there's 250 mils in the bottle? Might as well just read it straight from there. 3 seconds. Now this is a bit of a tricky one. What would the volume of water in the bottle be after 10 seconds? I would work it out with the rule. Volume is 50 times 10 plus 100. Volume is 600 mils. But that's according to the formula. We know the bottle is 500 mils volume, so you would say, however, the bottle is full at 500 mil. So this is a glitch in our question, but if you came up against that, you'd show the proper working to get the value according to the line, but then give the real world answer as well. Does the point 3, 2 lie on the line y equals 3x minus 6? So a line is just a collection of points. X is 3, and they reckon the point that we care about here has y value of 2. What we need to check is when x is 3, does this line have the value of 2? If it does, then the point is on the line. So it's like for this one saying, if t is 2, do we have 200 mils? Yes, we do. That's the only possible answer. If I said, does the point 2, 300 lie on the line? No, it doesn't, because when you put 2 into the rule, you get 200. There's only one possible answer for each value of x. So we substitute in x equals 3, y equals 3 times 3, take away 6, y is 9 minus 6, which is 3. We didn't get 2. The point that is on the line is 3, 3, not 3, 2. Therefore, no. That'll do. On the plane to the right, sketch and label these linear equations. I've got y equals 2. You go to y equals 2. Because it's just y, not y and x, you know it's a straight horizontal or vertical. And because it has to go through the y-axis, you know it's a horizontal line parallel to the x-axis. And you label it y is 2. X is negative 4. That's where x is negative 4 is. And you have to put a line that stays at that value. So a vertical line, x equals negative 4. Don't forget to label it. See, I can is done.